Hello students. Have you ever added the cost of snacks at a canteen, samosa, sandwich, juice, and then suddenly realize you're doing mathematics? Yes, that's what a series is. In math, when we don't just list numbers like in a sequence, but actually add them together, we form a series. For example, 2 plus 4 plus 6 plus 8 is a series. Now, if the list has a last term, we call it a finite series. If the list goes on forever, like 1 plus 1 half plus 1/3 plus 1/4, it's an infinite series. So, a series is simply the sum of sequence terms, and that small change, from listing to summing, unlocks powerful ideas in higher math. Alright, writing series term by term is tiring. Imagine writing 1 plus 2 plus 3 all the way to 100. That's where mathematicians invented a shortcut, sigma notation. We use the Greek letter sigma, which looks like a stretched capital E, to mean summation. For example, sigma from k equals 1 to n of a sub k means a sub 1 plus a sub 2 plus ... up to a sub n. So, if I write sigma from k equals 1 to 5 of 2k, it expands to 2 plus 4 plus 6 plus 8 plus 10. Much simpler, right? Sigma notation keeps our work neat and shows the entire sum in one powerful symbol. Now, let's look deeper at finite and infinite series. A finite series has a clear ending. For example, 1 plus 3 plus 5 plus 7 equals 16. 4 terms, job done. An infinite series never ends. Take 1 plus 1 half plus 1/3 plus 1/4, and so on forever. This series doesn't stop. But here's the twist. Sometimes, even with infinitely many terms, the sum can approach a fixed value. That's called convergence. So, finite series are exam-friendly. They always give a definite sum. Infinite series are conceptually deep. They connect to calculus and real analysis. Let's build series directly from sequences. Example 1. Suppose a sub n equals to n plus 5. First three terms are 7, 9, and 11. Series? 7 plus 9 plus 11 plus ... Example 2. A sub n equals 3 by 4 minus n that gives negative 1/4, negative 5/4, negative 9/4, and so on. Example 3. A recursive sequence where a sub 1 equals 1 and a sub n equals a sub n minus 1 plus 2. That gives us 1, 3, 5, 7, 9. Series? 1 plus 3 plus 5 plus 7 plus 9 plus ... See how every sequence has a partner series? Just put plus signs in between the terms. Now, some properties. Adding terms of a series is commutative and associative. That means you can rearrange or group terms of a finite series without changing the result. For any real sequence, we define the partial sum s sub n as sigma from k equals 1 to n of a sub k. That's the cumulative sum of the first n terms. A finite series always has a fixed total. But for an infinite series, we only define its value using the limit of partial sums. If the partial sums settle at a fixed number, the series converges. If not, it diverges. So, remember, partial sums are the key to understanding series. Let's solve a worked example. We are given a sequence as sub n equals bracket n minus 1 close times bracket 2 minus n close times bracket 3 plus n close. Step 1. Calculate terms. A sub 1 equals 0. A sub 2 equals negative 4. A sub 3 equals negative 10. A sub 4 equals negative 18. A sub 5 equals negative 28. Step 2. Form the series. That is 0 plus negative 4 plus negative 10 plus negative 18 plus negative 28. Step 3. Add. 0 minus 4 minus 10 minus 18 minus 28 equals negative 60. So, the partial sum s sub 5 equals negative 60. This shows how series captures the cumulative effect of a sequence, whether growth or decline. Let's wrap this up. A series is the sum of the terms of a sequence. We write it compactly with sigma notation. Sigma from k equals 1 to n of a sub k. Finite series always give definite results. Infinite series require careful analysis of convergence. Every sequence naturally generates a series, just at its terms. We've seen definitions, examples, sigma notation, finite versus infinite, properties using partial sums, and even a worked example. And that's the foundation of series, the bridge from sequences to summation techniques. In the next video, we'll explore how to sum special series like arithmetic and geometric ones. Stay tuned.